Hi, good morning, and welcome to Djuli or this Djuli webinar. So every week, ZP, as part of our kind of commitment to Djuli, and to make sure that essentially Djuli is supported, we like to do this webinar where we answer questions that have come in during the week. So let me jump straight into it. So this is a weekly webinar. Today's the 10th of October, but we like to do this webinar once a week just to really sort of answer questions that have come in specifically around Djuli. So this is a quick link to Djuli. There's a QR code here. I'll try and drag myself out of the way just slightly and go forward. Now, Djuli is I'm going to describe it as a data management system. It's specifically tuned for electrochemical data, but it can receive electrochemical data, you can store electrochemical data, you can share electrochemical data, and you can also manipulate it in terms of things like smoothing and area under curve and all sorts of stuff. So it says it there, data storage, data processing, and so it does have lots of these data acquisition as well. And data acquisition is something I really want to talk about now because I want to talk about its use with potentostats. So the background to this is there's a potentostat out there called the GalvanoPlot. It's a fairly low fairly low cost USB potentostat, and you can plug it in the side of a laptop and drive things like screen printed electrodes. I should already put a link to some of ZP screen printed electrodes because we do really have a very good quality of screen printed electrodes. So that's something I will talk about in the future. I think the thing that makes ZP screen printed electrodes quite unique is the reproducibility of them, especially our hyper value carbon electrodes. And I will make a touch upon that in some webinars. Just out of interest, if you have a decision point to go between carbon, gold and platinum, always try and choose carbon. It's both economical. It's about 1/32,000th of the price of platinum and gold. So it just makes for a much lower cost sensor or electrodes. And also there's things with platinum and gold, when you print them, or when you produce them, first of all, they're very pristine, but they very quickly kind of foul. And you have to kind of have this cleaning step when using these electrodes, either in R&D or in manufacturing. Anyway, let me go forward a bit further now with actually to say that Djuli is this sort of data management system that you can receive data, it can manipulate data, you can share data with it. And it works with a number of these potentostats. There's the AnaPlot from ZP, there's the EMA potentostat from ZP, there's the GalvanoPlot, which I'm going to talk about today. I'm specifically going to talk about amperometric data gathered using the GalvanoPlot. You can use it with PalmSense potentostats. You can also use it with Autolab, Metrome, DropSense. I do this because Metrome is the kind of parent company that then owns a brand of potentostats called Autolab and a smaller subsidiary called DropSense, which also has a potentostat as well. But we've uploaded data from all these potentostats. By the way, if you have trouble uploading data from a particular potentostat that you're using, please reach out to us because this is how this webinar's come about, because somebody was having a slight issue with uploading data from this GalvanoPlot potentostat, and we sort of showed them how to use it. We're also quite interested in people being able to use open source potentostats also with Djuli as well. I suppose some of the design rules will come out in today's video, because I'm going to show you that how I can manipulate the file from this GalvanoPlot potentostat to upload it to Djuli. Essentially, what you're going to see me do is take this, take a GPE file. This seems to be this file format that GalvanoPlot has. Change it to a text file just by renaming it, and then I kind of open up that file in Excel and just delete some superfluous information and delete one of the columns, and then it kind of works perfectly fine. I did mention that Djuli works with a number of other potentostats. One of them is EMA. EMA is a very small, elegant potentostat, and I'll actually put a link underneath the video as well so that you can find EMA. So it's a parallel potentostat. It can run six experiments at the same time, and as I say, I will put a link underneath the video on EMA. It's probably also worth saying that I also have a what I want to say. I want to say, first of all, I'm going to play the video, but I also want to say there is a webinar on the 25th of October. And I would like people to attend because it will be quite useful for actually finding out about Djuli as well. So let me just go a bit into how we actually dealt with this GalvanoPlot data. So what we did is we took the file name. I'm just going to turn something on here. We took the file name and I just want to check this. Yeah, we took the file name and we just I was using a PC, so most of the commands I'm going to talk about now are about using a PC. But what I was doing was I renamed the file using the thing and just going. It was a text file, so I just renamed it, and then just very quickly right-clicked it, renamed it so that it was a text file. So now it's a text file, and now I'm going to manipulate it using Excel spreadsheet and take off superfluous data. And I've got 3 columns here in the file. So what I'm going to do now is delete what I think is a superfluous column. So I think the middle column is really just telling us what this potentostat was at when we were actually when they were doing the experiment. So I knew it was 500 millivolts. So the reason being is I think Djuli is particularly set up to kind of expect potentiometric data or open circuit potential data or amperometric data or voltmetric data, but it's generally looking for sort of 2 columns. And I think the way I say they, I mean, I'm one of the founders of the company, but obviously we have quite a few, data scientists, and what we've done is set it up so actually it looks for sort of 2 columns of data. The reason I'm deleting a little bit more data here is that it seems to the experiment seems to have sort of be repeated in this file format, that there's a set of data, I recognize it, but then when I scroll down I find another set of data which seems to be just an absolute repeat of the first set of data. So I do end up deleting that as well. And so now I've kind of cleaned up this file, and I'm going to save it as it is. So I'm just going to save it as a text file, and then I would say it's kind of good to go. So now I got my Anapot text file here. Now I'll scroll Djuli across in a minute and then pull in or drag in, let's say, the this amperometric text file. So it's trying to load up the data at the moment. So I created a new report here. Now I want to sort of drag the data. First of all, I was going to do it by basically navigating, but I thought no, I'm going to just do a drag. So I just dragged it in. I'll just drag myself slightly out of the way here, and then what I do is I tell it it's continuous data. So we kind of consider amperometry is continuous data. So I say it's continuous data. It's amperometry. I close that down, and now it's just going to load up. Now, if you get any trouble uploading your GalvanoPlot data, just know that we're going to do these webinars. Well, we do these webinars once a week. So if you get stuck, don't worry. We'll sort of show you in live time through one of these weekly webinars actually how to do this. The reason I added a bit more to this was actually I realized that this data is actually quite noisy, and so I wanted to apply a filter to it. So we've got all sorts of data manipulation capabilities within Djuli, so it's a bit noisy. So I was thinking about, we're just using a moving average on this. So go into the amperometric continuous. I think it's not the world's, or amperometry continuous, it's not the world's best named data, but I'm just going to do some pre-processing. I was getting myself a bit confused here, but then I realized, no, I just want to, this is where I'm going to find it, the moving average. There's a lot of processing capability here. So maybe I should, in other videos, actually explore some of those smoothing algorithms a little bit more. But anyway, I'm applying this moving average, and then you can see the raw data, and you can see the news data. So to be fair, you haven't lost a lot of information by doing that smoothing window of 25 data points. I think it's worked quite well. So I think what I wanted to say with this is what I wanted to say with this really is this is how we are able to take that GalvanoPlot GPE file, change it to a text file, delete some superfluous information from the top of that file, then delete one of the columns from the file. So we're left with 2 columns, really just time and current. And then I noticed that there was actually a duplication of that data. I don't know why in that file, but I deleted the second sort of copy in that file and then just saved it and then just uploaded it to a text file. I told the Djuli database this was amperometry, and it was able to display it. And then I thought, well, because it is so noisy, I'll just put a smooth on it as well. So we just put a moving average with a window of 25 on it to smooth it out. But of course, I'm just showing you here that it's capable of this. If you get stuck or have any questions, don't hesitate to reach out to us. It's probably also worth saying that we do have live streaming webinars. The next one's on the 25th of October. We do one in the morning and one in the afternoon our time. And the one in the morning helps people in Asia to come on. It also works well for Europe, and then the one in the afternoon also works for Europe, but then also allows people in the Americas also to come on as well. So I'll put a link to that so you can find that and hopefully register. So I want to say thank you very much. As I say, the intention of this week's webinar was just really to demonstrate how to upload amperometric data from a GalvanoPlot potentostat into Djuli. And if you have any questions, don't hesitate to reach out to us. Okay, thanks very much.